Hi, welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is what is a neural network? This is the part one of a two-part series. So let's dig deeper into this topic. What is a neural network? Before we talk about the neural network itself, let's take a step backwards. Let's try to define what is a neuron, because neuron is a building block of a neural network. What is a neuron? The artificial neurons are inspired by the biological neuron. So the building block of a human brain can be classified as a biological neuron. And as you may have known, there's an average 86 billion neurons in a single human brain. And these neurons are sending messages throughout the human brain as small electric sparks. So let's look a little bit deeper into the biological neuron. So this is kind of simple representation of a biological neuron. And as you can see, it consists of a cell body. And on that top part of the cell body, you can see the nucleus. And the cell body is connected to dendrites. These are like a small units which can observe messages as electrical sparks. And then the cell body of the neuron is connected to the axon. And at the end of the axon, it consists of this terminal axon. So when dendrites get messages as electrical sparks, it communicates through the axon, and the output or the outcome of these messages will be delivered as a terminal axon, through the terminal axon. So these neurons are not just a single units, these are connected to each other. As you can see in this figure, terminal axon of a one neuron is connected to a dendrites of another neuron. So the messages, the neurons or the electrical sparks absorbed by these neurons delivered through the terminal axon to a dendrites of another neuron. And this is happening in this connection between the dendrites and the terminal axon, which is called the synapse. So how this biological neuron works, it has inputs and outputs. As you can see, inputs or the electrical sparks delivered through the dendrites of this neuron, and then these electrical sparks go through the axon of the neuron, and at the end, terminal axon deliver the output as another electrical spark. So then, can you build a new mathematical model for such type of a neuron? I mean, the artificial neurons are inspired by this biological neuron. So as we have discussed, there are inputs, there are outputs, and there is a activation function. When you're building a mathematical model, these are kind of three building units you need. One is the inputs, other one is the system model itself, which is this case we call this activation function, and then the outputs. So let's have some idea about how these biological neurons are functioning. So if you think about this biological neuron get a single spark, or it connected to another terminal axon, and it's get some sort of a electrical spark or a message. Often what happen, it won't excite itself for a smaller amount of electrical energy or electrical spark. So as you can see, there are no outputs coming out of this terminal axon. But if you think about a different situation where you have a multiple inputs, where you have a multiple electrical sparks being delivered by other neurons through the dendrites of this neuron, what happened in this situation, this neuron get enough electricity to excite itself. And then when its body get excite itself, it will release another electrical energy as a sparks. So that electrical energy will deliver through the terminal axon as a output. In general, you get a single electric energy as output, but from different terminal axons can deliver these output into a multiple direction. So this is the kind of behavior for biological neurons. So this idea being adopted towards these artificial neurons. So let's try to make a mathematical model for an artificial neuron based on this simple concept. So in the first part of this discussion, I mentioned if a neuron received a single spark or a small amount of electrical energy, it will not excite itself. So in this activation function, as you can see, that part of the activation function is showing that when you get to some amount of inputs, there are no outputs. So that means up to a certain threshold level, the electrical energy received by one neuron will not excite that neuron itself. So that is the first part of this activation function. So if you're looking into the second part of the activation function, what happened after a certain threshold level, the amount of electric energy or the sparks getting into this biological neuron is beyond that threshold level. So then the neuron itself will activate it and start firing or sparking, sending these electrical sparks into the adjacent neuron in this human brain. So that is represented by this second part of this activation function. So this activation function is called the unit step function. So now we have modeled this biological neuron into inputs, activation function, and output as one of the mathematical model which we can use in a later stage when we are describing more complex neural networks. So the next question would be, are there more activation function? Of course there are. So the unit step activation function is on the top, which is we have described previously. And then this signum function, and the behavior, special behavior in this function would be instead of a zero output, it can create a negative output when it's beyond a certain threshold value. And the linear activation function, the input and output will have a linear relationship. And then the piecewise linear function, it is kind of combination of this linear function and then the unit step function. So certain threshold level, the function give a linear output, and beyond that it will give this unit step type of output. And then there are logistic function and hyperbolic tangent function also being used in the neural network community. It has this logarithmic behavior. And then this ReLU function and then rectifier functions are one of the most popular activation functions used in this modern neural network community. So that is the kind of end of my presentation. Hopefully you have enjoyed that